Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2024. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 says, a student used a steel sphere in an experiment to determine the viscosity of a liquid. The student used vernier calipers to determine the diameter d of the steel sphere. The student recorded a single measurement of d as 12.7 millimeters. Determine the percentage uncertainty in this measurement. In all the papers, you need to understand how to calculate percentage uncertainty for a single measurement. So let me explain you a little bit about this one. For a single measurement, if just one measurement, then how to determine percentage uncertainty for a single measurement. Percentage uncertainty will be equal to half of least count, half of least count of instrument. Least count of instrument means the instrument you are using to take measurement divided by the measurement you have taken. So simply divided by the measurement you have taken, and this all you have to multiply by 100. So this is percentage uncertainty. So you have to understand the least count of different instrument. Least count of meter rule is 1 millimeter. So divided by 2, that is 0.5 millimeters. And least count, let me write down here, for meter rule, the least count means the one smallest division on that for meter rule is 1 mm. This is the smallest measurement on meter rule, smallest division on the meter rule. And for vernier caliper, you need to understand for vernier caliper is 0.1 mm, and for micrometer screw gauge, so I'll be writing here simply micrometer screw gauge is 0.01 mm. So here we are using vernier caliper, so you have to take half of least count. So it means that percentage uncertainty in this case will be equal to half of this value, means 0.1 mm, and this is divided by 2 divided by measurement, that is 12.7 mm. So you have to be careful. So this is, here you're using millimeters, so this also has to be in millimeters. You cannot use here centimeter and here millimeter. So you have to be consistent with the units as well. So if this is millimeter, this also has to be in millimeters. So we need to calculate percentage uncertainty. So you also need to multiply this one by 100. So here we will write down 100. So if we simplify this one, we will get 0.05 millimeters, and this is divided by 12.7 millimeters multiplied by 100. Very beautiful thing, very important thing you need to understand. These units must be cancelled. If these are two different units, it means percentage uncertainty is not correct. So these two units should be the same. Now if we simplify, in this case we will get 0.394. So you can see the raw data, given data, it has 3 SF. So your percentage uncertainty can have 3 SF. So this is how we need to answer. I hope this makes sense to you. And now let me explain you. For repeated readings, how to calculate percentage uncertainty for repeated readings. So percentage uncertainty will be equal to half range divided by mean value. So you will take the mean value of repeated reading, mean the given measurements, you will take the mean value of them, and you have to multiply this one by 100. Half range means maximum value in the given measurements minus the minimum value, that is range, then you need to divide by 2. So let me write down here, so to make it clear to you, half range simply means that maximum reading measurement minus minimum divided by 2. So this is how you need to calculate, and this is very important point. And every paper, in every past paper, they have asked about this one. So you need to be very clear how to calculate percentage uncertainty for single measurement, and also how to calculate percentage uncertainty for repeated measurements. Second part says the student repeated the measurements of D at different orientations and calculated the mean. Explain another technique she should use to determine an accurate value for D. So this is one technique. Different orientations and calculate mean. This is one way to reduce random error. So this is one way to reduce random error. So it will minimize, in this case, random error. So when you calculate mean value, you can minimize random error. But by calculating mean value, you cannot eliminate systematic error. Now, what is another possible technique? For example, when we're using this kind of instruments, we need to check for zero error all the time. When you're using vernier caliper, when you're using micrometer, you must check for zero error. So we can say check for zero error. So this is one thing you can say, check for zero error. So this is very important one. So check for zero error. Check for zero error and correct. So finally, when you take your final measurements, you have to correct as well, and correct final answer. So we can say and correct final answer. And what is the purpose of this one? By checking for zero error, we can minimize or we can eliminate. So we can minimize, or you can say we can eliminate systematic error. So systematic error. They can also ask you, give an example of systematic error. So what is example of systematic error? So example of systematic error is zero error. So zero error is an example of systematic error, because if there is a zero error, your all readings will be on one side of actual value. So let me explain you a little bit about this one. So let's say this is the actual value. If there is a zero error, your all readings may lie on one side higher than actual value. So we can say all your values, they will be higher. And it is also possible all the values, they are smaller than, they can be lower. So if you calculate mean value, it will not eliminate systematic error. Readings will be higher, all the values, or all the values will be lower. So this is systematic error. So you can see this instrument, if you look at this one, these two zeros, you can see zero of main scale and zero of vernier scale, they are in front of each other. So it means this vernier caliper, it has no zero error. So we can say no zero error. So we always check for zero error when we use vernier caliper and micrometer. Third part says, describe how the student should determine a value for the density of steel. Density of steel. So how we can calculate density of any object? Density is equal to mass over volume. And then you need to mention how you will measure the mass. So we need to use balance to measure mass. So you can say use balance to measure the mass. How we can determine the volume? Volume is equal to 4/3 pi r cube, because this is a spherical object. To determine radius, with the help of vernier caliper, we can only find diameter. So to find radius, we can simply say divide diameter by 2 to find radius. And then use the formula, and then you can say use density is equal to mass over 4/3 pi r cube, and you can find the density. So these are the points you need to write down for the answer of this question. So this question has 3 marks. The first mark you will get if you have mentioned you will measure mass using balance, you will get 1 mark. And the second mark you will get if you have mentioned divide diameter by 2 to find radius. So this will be the second mark you will get. And the third mark you will get if you have mentioned about this formula. So this is how these 3 marks will be awarded to you. So when you read questions, first try to understand question well. When you understand question well, everything will be given to you. Then simply you have to use your basic understanding of physics to figure out the answer. Part B says the student placed the steel sphere in a transparent tube filled with liquid. She arranged the transparent tube as shown in the figure. The student used a stopwatch to measure the time for the steel sphere to travel between the rubber bands. Describe how she should ensure that the steel sphere is traveling at terminal velocity between the rubber bands. You should include any additional operators required. So for this question, we need to determine the terminal velocity, and terminal velocity will be equal to the distance traveled divided by time taken. And this distance, how we can measure? We can measure this distance using meter rule. So if you write down this point, you will get 1 mark. And second, this distance is the distance between rubber bands. So we have to specify what distance we are talking about. So you can say distance between rubber bands. So you will get 2 marks only just writing these 2 points. Distance between rubber bands. So this is distance between rubber bands. Now we need to also specify this one, time. So what time we are talking about? In the question it is already given to you. Student use stopwatch to measure the time. So if you simply write on use stopwatch to measure the time, you will not get any mark. So how we can get mark for this step? So we can say start and stop stopwatch, start and stop stopwatch for the same point on the sphere, for the same point of the sphere. So let me explain you what exactly it means for the same point of the sphere. So it means that let's say rubber band is here. So when sphere is at this point, when just the front of the sphere is crossing rubber band, we start our stopwatch, and when front crossing the second rubber band, we stop our stopwatch. So this means start and stop the stopwatch for the same point of the sphere. Start and stop the stopwatch. So you will get 1 mark for this one as well. So if you have written use meter rule to measure the distance between the rubber band, you will get 2 marks. One for the name of the instrument and the second for specifying the distance between rubber band. So here you will get 3 marks. So this is 1 mark, means total 3 marks. How about the 4th mark? So until now we haven't specified how we will make sure it is terminal velocity. So for that purpose, we can move this rubber band. Let's say we move this rubber band from here. Let's say this is position A and this is B. Rubber band was here. Then we can move this rubber band a little bit up. We can place here at C. So we will find VT between A and B. That will be equal to the distance between A and B divided by time taken between A and B. And we will find V between A and C, and we will measure the distance between A and C, and we will divide by the time taken between A and C. If VT, so here we can also say VAC, or you can say this is VT. So we can say this is VT AC. If VTAB is equal to VTAC, it means terminal velocity. So sphere has reached terminal velocity. So we can say it has reached terminal velocity if it is true. Still sphere is traveling at terminal velocity. So if these 2 values are same, it means it has reached terminal velocity. So its velocity is constant. So this is how you need to answer. So for writing this fourth point, you will get another mark. So this is how 4 marks will be awarded to you. Part C says the student determined the viscosity of the liquid as 0.72 Pascal seconds with a percentage uncertainty of 6%. The viscosity of castor oil is 0.65 Pascal second. Deduce whether the liquid could be castor oil. So first of all, we need to understand what is given to us. So this is our calculated value. So calculated value is 0.72 plus minus 6%. So it has range of values. So here we can say it has upper value, or you can say upper limit, and this one has also lower limit. So we can say it has lower limit. Now you need to understand how to determine the upper limit and how to determine the lower limit. For upper limit, we can calculate simply. This will be equal to 0.72 times 1 plus, this is 6%. It means this is 0.06. So you can calculate upper limit. And lower limit we can calculate, that will be 0.72 1 minus lower means 100 minus 6, or you can say 1 minus 0.06. So this is how we can determine the lower and upper limits. As this value is smaller than calculated value, so this is the calculated value. If the lower limit is below 0.65 or equal to 0.65, it means that liquid is castor oil. It could be castor oil. If higher, it means it is not in the range, so it cannot be castor oil. So now simply we need to calculate this one. If we calculate this one, we will get 0.68. So the lower limit is 0.68, but viscosity of castor oil 0.65. It means that liquid has higher density, so it cannot be castor oil. So we can simply say as lower limit. So you can say as lower limit is greater than 0.65, so it is not, so the liquid is not castor oil. So this is how you need to answer. So it is not castor oil. Alternate approach, and other way, this is a common approach you can use all the time. We can say alternate approach is a very common way of answering this type of questions, and this type of questions are also very common, so you need to understand how to deduce. Second approach is we can calculate percentage difference, and we already have percentage uncertainty, so we can calculate percentage difference between these two values. So we have 0.72 minus we have 0.65. We can divide by 0.65 and we need to multiply by 100. So if we calculate this one, we will get about 11%. So this will be the percentage difference. Now if, as in this case, percentage difference is greater than percentage uncertainty, so not in the range, so simply you can say not castor oil. So you can say not castor oil. So we are talking about not castor oil. So this is another way to say, if for example percentage difference was lower than percentage uncertainty, then it will be castor oil. So this is a common approach you can always use. You can calculate percentage difference. If percentage difference is higher than given percentage uncertainty, it means not in the range or not that liquid. If percentage difference is lower than percentage uncertainty, it means it is in the range, so it means it can be that liquid. So this is how you need to answer, and these two approaches you need to master. Question 2 says a student was given a sealed box that contained some electrical components. The sealed box could contain a diode, resistor, filament bulb, are a combination of any of these components. The student could not see the components inside the sealed box. Two terminals X and Y on the sealed box enable the student to connect the components to a 6-volt power supply and fixed resistor. The student investigated the current potential difference characteristics of the sealed box. Complete the diagram to show the circuit the student should use for this investigation. So the important point is the student is investigating the current potential difference. So it simply means that the student is planning to sketch a graph between V and I. So here V and I. So we need value of V and we need value of I. Means V across this one. So we need V across this one. So we can use voltmeter. So simply you can use voltmeter here. And we have 6-volt power supply. So we can also connect the power supply here. So let's say this one is power supply. So power supply is connected here. In this case, we need different values of I. So we need to change the resistance of the circuit. So we need variable resistor. We need to change the resistance of the circuit, mean the total resistance. So we need variable resistor. And we need to measure current in the circuit. So we need to connect ammeter in the circuit as well. So this is how we can connect the circuit. So if you have drawn circuit like this, you will get 2 marks. Now let's go to the second part. For the second part, it is given to us the student was told that the sealed box contained a diode. Explain why the resistor R is needed in the circuit. Now it is given to us, it is given that sealed box contain diode. And now we need to explain why resistor R is needed in the circuit. Resistance in forward bias. So we need to understand few points about diode. In forward biased, resistance of diode, we can say diode resistance is very low. So we can say resistance of diode is about 0, means is very low. So if the resistance of diode is very low and we don't have this resistor in the circuit, so current in the circuit will be very high. So we call this resistor, actually we call this is safety resistor. And very important point, you need to understand why we are using this fixed resistor in the circuit. So this is called safety resistor. So how we can answer this question? This question has 3 marks. So first mark you can say fixed resistor will limit the current. Fixed resistor will limit the current in the circuit. Will limit the current in the circuit. So current will not be too high. The second you can say in forward biased. In forward biased, resistance of diode is negligible, is very small. So current in the circuit, third point you can say current in the circuit will be very high. So current will be very high. So you can mention these 3 points, and this is also typical question you will see in many past papers. Third part says the student had a choice of resistors to use for the resistor capital R as shown in the table. The student was told that when the potential difference across the sealed box is 0.7 volts, the current must not exceed 200 milliamps. Deduce which of the resistors he should use. So first of all, we can simply sketch the circuit, and in the circuit we have the box. It has 2 terminals, and we have fixed resistor, and also we have connected ammeter. So this is the ammeter. So this is our basic circuit, and here we have voltmeter that is connected across this sealed box. Reading on this one is 0.7 volts. Now if we connect voltmeter across this fixed resistor, let's say this is V1, and reading on this one has to be equal to 6.0 minus 6.0 minus 0.7 volts, so we will get 5.3 volts. So here we will get 5.3 volts. So this is the reading on this voltmeter. Now we have value of current, we have V, we can find the value of resistance. So R in this case should be equal to 5.3 volts divided by 200 milliamps. So this is 10 to minus 3, and this will be equal to 27 ohms. We can also calculate the maximum power when PD is equal to this one, means the maximum power dissipated. So we can calculate P max. That will be equal to 5.3, this is V square divided by R, and the value of R is this, means this value we are talking about. So we can use this resistance, or we can use this resistance, because this is the value of R. Minimum value of R, we need this one. If the value is greater than this, current will be lower than this value. Now if we solve this one, we will get 0.85 watts. So at this value of V, the maximum power dissipated by this resistor is equal to 0.85 watts. 0.85 watts. As 0.85 is lower than 2.0, so it means we should use this one, because this maximum power is lower than this value, so this will not work. So we should choose this one. So the answer for this one should be, we should choose resistor D, because its maximum power is greater than power dissipated at this value of V. So this is what we need to choose. Part B says the student plotted the graph below. The seal box contained a diode and a resistor. The diode and resistor were either connected in series or connected in parallel as shown below. Explain whether the diode and resistor were connected in series or in parallel. So first of all, we can simply draw the circuit. So let's say this one is our circuit, and here we have diode. So this is diode, and here is resistor. They are connected in series. If they are connected in series and we sketch a graph between I current on y-axis and V on x-axis. So we can draw these arrows here. So what will be the shape of the graph? So when V is positive, mean it is connected in this direction, so we will see the shape of the graph somewhat like this, and on this side it will be about 0. V is increasing, but current has to be 0 when the potential is negative. When potential is positive, so I is increasing, it will be very high. And when PD is negative, means when we change this battery, we reverse this battery. So let's say this side is positive now, positive terminal, this is negative, so there will be no current. But in the graph we see current, it means it is connected in parallel. And so how we can answer? So we can say the graph shows current. So we can simply say the graph shows current when PD is negative. We can say when PD is negative, potential difference is negative, mean we change the polarity of the battery, it's negative, so therefore connected in parallel. So we can say connected in parallel. So this is how you can answer. If they are connected in series, I should be 0 when PD is negative. Third question says a student determined the refractive index of a liquid using the apparatus shown in the figure. The student filled the tall beaker with water. He used a meter rule to measure the depth H1 of the water. Describe an accurate method to determine a single value of H1. So the first thing we need to understand, we need to measure height. So we will be using meter rule, and this is already mentioned in the question. So if you simply say use meter rule to measure height, you will not get any mark, because this is already given in the question. Use meter rule to measure the depth H1 of the water. So how we can measure accurately? So the first thing we can say is that clamp meter rule. So clamp meter rule. So we can clamp this meter rule in retort stand. And meter rule, actually it should be in front of the beaker. So you can say this glass is a beaker, so meter rule should be here. Meter rule should be here, close to the beaker. It's very important one, close to the beaker. So this point is very important. So second point, you can say place meter rule close to the beaker. So very simple points, you need to just write down in detail. Place meter rule close to the beaker. So close to the beaker, so you will get second mark. And also we need to check. So third point, you can say, so when you place your meter rule, so let me place here, we clamp meter rule here, let's say it is clamped here, is close to this one. So it just a little bit away, but you can imagine this is very close. Or let me draw again. So this has to be close to the beaker. So let's say we just draw this one here. So this is just close to the beaker, but we need to make sure this one should be vertical. So we can say use set square to check it is vertical or not. Make sure, so we can say make sure meter rule is vertical. Meter rule is vertical. Meter rule is vertical with help of set square. So you will get another point. We can also, now the fourth point means you can say we have to read now the scale. So how to read the scale? Read perpendicular to the scale. So read perpendicular to the scale. So you have to read perpendicular to the scale. Means if the scale is here, you have to read perpendicular, not like this, not like this. So perpendicular to the scale. So you can say this one. You can also mention, you can use set square. For example, at this point you can check this meniscus and the reading on meter rule using set square. So this is over set square, so we can align and we can measure as well. So these points, if you mention, you will get the mark. Part B says the student placed a steel nail at the bottom of the beaker. He viewed the search pin and the image of the steel nail from above while adjusting the height of the search pin. While the search pin appeared to be in line with the image of the steel nail from all angles, he measured the value of H2. The student varied H1 by adding more water and repeated the process. He recorded the following data. Criticize the recording of the data. So if you look at this given data, we have only 4 points. Only 4 measurements are not enough. So first thing you can say 4 measurements are not enough, or you can say 4 data points are not enough. So we can say 4 measurements are not enough to draw a valid conclusion. Valid conclusion. So this is one thing we can say. And the second thing we can say, no evidence of repeat readings. So when we do experiment, we should repeat. So there is no evidence of repeat readings, you will get the second mark. So these 2 marks are common, points are common when you need to criticize the data. And the third point, now if you look at the data, if he is using the same instrument, number of decimal places should be the same. But in this case, this has 1 decimal, this has no decimal. It means he is using 2 different instruments. If we use the same instrument, number of decimal places should be same. So we can say in this case, the values are not recorded. Values are not recorded to consistent decimal places. So consistent dp means decimal places, you can say decimal places. So this is the third point we can say. And the fourth point we can say, this value 37.3, for example, this is 451. How it is possible? So we can say the final value of H2, final value of H2 does not follow the trend, does not fit the data, or you can say does not follow the trend. So this is increasing by small amount, but this increased suddenly, so it does not follow the pattern, it does not follow the trend of the data. So this is how you can criticize. And one last thing I want to emphasize again is that if you're using the same instrument, same number of decimal places is very important. Same instrument. If you use one instrument, if you're using meter rule, for example, number of dp has to be the same dp. So this is identification of instrument. Now if I look at this one, this is telling me he's using maybe vernier caliper, he's using meter rule. Actually this is telling us is using meter rule, but this is telling us an instrument which is less accurate than meter rule he is using. This is telling us he is again using meter rule. So this data is does not have consistent decimal places. So it means student keep on changing instrument, or student is not recording data in a proper way. Part C says the student used values of H1 and H2 to calculate values for the refractive index N of the liquid. His values of N are given in the table below. Calculate the mean value of N. Very straightforward question, simply is asking you use these values to calculate mean value. So mean value simply we can say, so the mean value, very common question, so every year you will see they will ask you to calculate mean value. So in this case we have 1.38 plus we have 1.41, so this is 1.41 plus we have 1.33 plus we have 1.29, and this has to be divided by number of readings. So if we do this one, we will get 1.353. So you can use 3 significant figures, or you can use one more, that is acceptable. So even if you write on 1.35, that is also acceptable. You can say 1.35, so that will be acceptable. The number of significant figures in the final answer should be equal to the least number of SF in the given data. So you can say 1.35. This is also acceptable. Next one, we need to calculate the percentage uncertainty. So percentage uncertainty, so we need to understand how to calculate percentage uncertainty. Percentage uncertainty should be equal to the half range. So half range divided by the mean value. So we can say divided by mean value. And this one should be multiplied by 100 because we are calculating percentage. So we need to find the half range. So in this case, what is the maximum value? This one is the maximum value and this one is the minimum. So we can say this is maximum, this one is minimum. So we need to find the half range. So we can say half range. Half range will be equal to 1.41 minus 1.29. This is divided by 2. So we will get 0.06. So our half range is 0.06. Mean value is 1.35. And we can multiply with 100. So if we solve this one, we will get 4.4%. If you also want to use 3SF, you can say 4.4. It doesn't matter. You are using 2 or 3 SF, so it is acceptable. So 4.4%. So this is how you can calculate. These are typical questions. You need to understand how to calculate mean. You need to understand how to calculate percentage uncertainty. You need to understand how to calculate half range. Question 4 says a student determine the mass of a meter rule using the apparatus shown in the figure. When the meter rule is in equilibrium, the relationship between the distance k and the distance L is given by this formula, where MA is the mass of mass A, MB is the mass of mass B, and MR is the mass of the meter rule. Explain how a graph of K against L can be used to determine the value of MR. Value of MR. Now this equation is given to us. We need to sketch graph between K and L. So this is the first thing we need to understand. Now we can compare this straight line equation. So we can write down Y. This is equal to mx plus c. So we have to compare these two equations now. So from here you can see this is m. So this is the gradient. So we can say in this case gradient means m. This is equal to mb divided by ma. So this is the gradient. And y-intercept from here we can also find out. So y-intercept from here will be equal to 0.2. This is mass of meter rule divided by mass of A. So this is A. Now if we have y-intercept, we can find MR. So simply we can rearrange. We can say in this case MR will be equal to M sub A times the value of y-intercept. We'll say value of y-intercept, and this one has to be divided by 0.2. So that's all what you need to do. Simply you need to write down this one in linear form, and then you can find out how you can find value of MR. So that's the main point. So this is basic skill. You need to understand if the equation is given to you, equation of straight line is given to you, how to find y-intercept, how to find gradient. So simply you have to compare with straight line equation. So in this case this is y-intercept, this one is the gradient. So this is how you need to figure out. For part B, values of K and L are given to us, and we need to plot a graph of K on the y-axis against L on the x-axis on the grade opposite, and we need to determine the gradient of the graph. So let's go to next page and sketch the graph. So here you can see I have already sketched this graph. So let me highlight some points you need for this graph. First of all, you have to label the axis, means the quantity on the y-axis and the unit, and quantity on the x-axis and the unit. So this is, if you have done this part, you will get 1 mark. And the sensible scale is important. So reasonable scale, if you're using on x-axis and also you're using on y-axis, you will get another mark. And the third mark you will get for the best fit line. And if you have also plotted points correctly, you will get 4 marks for this one. So this is our best fit line. You can see this point is little above the line, so I can mark this is little above. So you can see this point is also slightly below, this point is also slightly below, so this is also slightly below. So this line fit these data points, so we can say this line is best fit line. So this is how your line should look like. It should fit all the points. So this is how you need to sketch the graph. Now we need to determine the gradient of this one. So we can take on any 2 points on the line. You have to take points from the line, not from the given, means not from this data. So we can choose any 2 points. So in this case I'll be choosing this point, then I'll be choosing this point. Coordinates of these points are 0.65, as you can read this is halfway, it is here 0.65 comma this is 0.220, as you can see from here. And this point is, I can say this is 0.10 comma this is 0.086. So these are the points, 2 points we have. So we can find the gradient now. So to find the gradient, we can find delta y by delta x. So in this case delta y we have, that is 0.220 minus 0.086 divided by, we have 0.65 minus 0.10. 0, and we can find out the gradient. So this is how you need to calculate. So let me show you a better way. So it's very important you can draw this triangle. As you can see here, I have drawn this triangle, so it is very easy to see now, and the length of this one should be longer. You cannot take 2 points very close to each other, so it has to be more than half of the total length of this hypotenuse of this best fit line. So take points away from each other. Now if we solve this one, we can find the value of the gradient. That will be equal to 0.244. As this is a ratio, because this has unit of this one is meter, so it means gradient has no unit. So this is how we need to determine. So this question is very common. Every year you need to sketch the graph and you need to find the gradient. Sometimes they will ask you to calculate the y-intercept. So this point need to be clear to you. Now let me make it clear to you for the y-intercept. So let me make this point clear. So when you can read from the graph, when you cannot read. So we can say y is equal to mx plus c. So if x is equal to 0, so this quantity will be 0. So then in that case you can say c is equal to y. So y will be equal to c. You can read from the graph if x is equal to 0. So in this case we are starting x from 0. So this is the value of y-intercept. You can read directly. But if x is not 0 at the origin, at this point, you cannot read y-intercept directly from the graph. So x has to be 0. Then y-intercept is equal to reading on y-axis. Third part says determine a value for MB, and MA is given to us. We have already compared this equation and we have found that gradient is equal to MB divided by MA, and we need to find the value of MB. So simply we can say MB will be equal to the gradient we have calculated times MA, and the value of gradient we have calculated, that was 0.44, and value of MA is 0.40. So we have 0.400. So if we solve this one, we will get 0.097 kgs. So this is our final answer. So this is how you can figure out value of MB. Part 4 says determine a value for MR, means mass of the meter rule, and we have already discussed in part 1 that mass of the meter rule, this is equal to y-intercept. This is equal to y-intercept times MA, and this is divided by 0.2. Means simply we are using this one. This is equal to y-intercept, and if we rearrange, we will get MR. This is equal to y-intercept times M sub A divided by 0.2. Now we need to find out value of this one, and y-intercept we can read from this because x-axis at origin value of x is equal to 0. So at here value of x is equal to 0, so we can simply read y-intercept from y-axis, and if we read this one, this value is equal to 0.062, and value of M sub A, it is given in the last part, that was equal to 0.400, and this is divided by 0.2. Now if we solve this one, we will get 0.124 kgs. So this is mass of meter rule, and this is the answer of this question. I hope this video was helpful. If you have any questions about this paper or from any other paper, you can leave your questions in comments. I will try to answer as soon as possible. And if you're looking for extra resources, please join Patreon, and on Patreon you will see a lot of resources. See you in next video.